If you are new here, you can see all of our previous sessions on the spatial series on the Ask Tom webpage. You can use this QR code here to get to that. And if you have any ideas for future sessions, you can send an email to our colleagues Corinne and Hans, and they will take your ideas and use them. We just asked for a 2-week lead time before the next session. With that, I will hand it over to Veronica to show us her demo. Thanks, Veronica.
Thank you. Okay, let's share my screen. Okay, so welcome and thank you for joining the Analyze Spatial Data with Python, GeoPandas, and Oracle database session. I was already introduced, but just so that I add, I'm a product manager in the Oracle database group, and I'm managing the open source programming languages drivers such as python-oracledb API for connecting to the Oracle database. And my experience in the spatial space is limited, but today I would like to show you a demo on how you could use the power of Oracle spatial data to start up a new coffee business from scratch, or expand your business if you already have it, and get informed decisions on strategizing the best locations for new coffee shops in a mega city. I'm gonna use New York as an example. But first, before I get there, I wanted to just give an agenda of what I'm gonna cover today. So we'll start with the spatial data analysis with Python, GeoPandas, and Oracle database. So I'm just going to give a brief introduction to the python-oracledb API. And I'm going to introduce the GeoPandas, Shapely, and Folium packages, which are used for spatial data analysis and data visualization on maps. And I will conclude, or let's say like majority of this presentation is going to be centered around this demo of a real world business case on how to build this coffee shop empire. So we'll end the session with wrapping up and me sharing some useful resources that might help you to get started, to be hands-on, and maybe potentially run a similar script that I'm going to demo in a minute. Okay, so how do we perform the spatial data analysis? So the data is stored in Oracle database and Oracle Spatial. You are already familiar with those. And then Python provides an environment for data analysis and machine learning. Python OracleDB driver enables connectivity and robust access to the Oracle database. And then we are going to leverage Python geospatial packages such as Shapely, which is used for the manipulation and analysis of geometric objects, and then Folium for visualizing data on interactive maps. Now you will see that in my demo, I'm going to present everything in a notebook, in a Jupyter notebook. So I'm using Jupyter Lab and notebooks for presenting the analysis in a structured format. So I'm going to run everything live. Okay, so let's get started. Spatial data analysis with Python, GeoPandas, and Oracle database. I'm going to give initially a brief introduction to Python OracleDB driver. If you're not familiar with it, here in this diagram, the Python OracleDB driver sits in the middle and is loaded by Python. It gives an API that you can call, and it connects to the Oracle database for all standard relational and JSON operations, including SODA. So what do you need to know? In May 2022, to make our developers and users' lives easier, we released a new renamed version of CX Oracle, if you're familiar with this driver. So we named this new release Python OracleDB. So this is a major upgrade of CX Oracle 8.3, and the Python OracleDB driver enables direct access to the Oracle database through its thin mode. So one way to think about the upgrade is that we added a thin mode to CX Oracle and made this mode the default. Now, the database can be on the same machine as Python or remote, by this allowing you connections from platforms that don't have Oracle client libraries installed. The driver comes with an easier deployment and a smaller installation footprint, resulting in better use of resources and better performance. And because of this thin mode, which is the default mode, does not need the client libraries. This lets you play with it on platforms such as Apple, Silicon, and, for example, IoT devices. The driver is still a binary module needed for performance, and it has an optional tick mode, which does use those Oracle client libraries. When you enable the tick mode, this is making it the same as CX Oracle. CX Oracle operates in tick mode. So the tick mode offers a runtime choice to run it in tick mode. And some advanced functionality, it's only available in tick mode. So if you need to use advanced functionality, for example, NNE or ACTAC, these are only available in tick mode. And our team is working on bringing this in tick mode too, so you don't need those libraries, client libraries installed at all. In terms of support, we have support for Python 3, and then we continue to support Python's database API v2 specs in both thin and thick modes, which means that it works with frameworks and ORMs such as SQL Alchemy, Django, Pandas, and so on. The driver is still open source using GitHub for its repository, and the license got updated to Dual Apache 2 and UPL. Okay, let's introduce the GeoPandas. So GeoPandas is an open source Python library designed to work with geospatial data. It extends Pandas library for spatial data, and then it has two main structures. The first one is the geodata frame, which is storing the geometry columns and performs special operations. And then the second structure is the geoseries, which handles geometries. Now, GeoPandas can be installed with pip command. If all dependencies are installed correctly, you will notice the dependencies below. So you issue a Python pip install GeoPandas, and then in the Python script, what you need to do is you have to specify import GeoPandas, and that's mainly it. You can use all the functions which are within this package. Now, Shapely is a package allowing to perform post-GIS type geometry operations outside of an RDBMS. So it provides the spatial type used to populate the geometry column, and then allows working with geometry classes such as points, curves, surfaces. And then the geometry values are in WKT, which I believe stands for well-known text format, since this is the format used in a geodata frame. Okay, so the GeoPandas, this is just like more details on the GeoPandas. GeoPandas extends the common data type used in Pandas to allow for the many and unique geometric operations. So I mentioned GeoSeries and GeoData frame, which stores the geometries. A geodata frame is mainly a data frame with the additional geometry column. So if you're familiar with Pandas and data frames from Pandas, the data frame in GeoPandas mainly is similar to that, where you add this geometry column on top of it. So the geodata parameters that you need to know or remember, these are important ones, are the CRS, which represents the coordinate reference system of the geometry objects. So for example, you can have the EPSG 4326, and then the geometry. And then when a spatial method is applied on a geodata frame, it will act on the geometry column. Okay, so let's talk about visualizing geospatial data with Folium. Folium is a library used to visualize the data manipulated in Python on an interactive leaflet map. It has built-in tilesets from OpenStreetMap, Mapbox, and Stamen, and it supports custom tilesets. Now, to install Folium, you have to issue, similarly to the previous package that I presented, you just issue a pip install command. So you do pip install Folium. And after having the libraries installed, creating a map is as simple as one line of code. So you just call this map function. So you do folium.map, and then you specify in the parameters the location. So you specify the longitude and latitude coordinates, and then you specify what kind of tiles you want to use to display this on the map. these coordinates on the map. So in this case, we are using the CartoDB positron, and I think this is also a default in Folium. Now, this will automatically generate an interactive map and output in a Jupyter notebook. So I will show you when I call this function, where you will be able to interact with the map. So you can actually play with it similarly to what you play with the Google Map, for example. You can zoom in, you can zoom up, zoom out, you can just like reposition the map and so on. The function map takes some optional arguments as well, and we are using a pop-up, an icon, and we could also specify this zoom that I mentioned. If it all goes well, you should see the map like this one, which is displayed over here on the slide. Now, the true power of Folium comes from combining the mapping capabilities of the library with the data manipulation power of Python. And Folium provides built-in support for visualizations in any marker type. So I'm gonna change that so I can show you what you can do when you specify different icons to visualize those points on the map. So let's put everything together. These steps are also performed in the demo later. So for loading and visualizing geospatial data, we'll start with loading GeoJSON data into an Oracle database tables for persistence, and to later apply the Oracle spatial functions on the spatial data. Just to give an example, I'm going to use this SDONN and SDONN distance. And then secondly, we fetch the spatial data from the Oracle database using the python-oracledb driver that I introduced earlier. And then we create the GeoPandas geodata frames from Oracle database data. And then ultimately, we use Folium and Shapely for visualization techniques to display all this spatial data on a map. For data manipulation, we use attribute-based query and filtering, or I should say, like for data preparation and manipulation. Attribute-based query and filtering, and special operations such as intersection and union. You will see them in the demo. And then for geospatial analysis, we are using spatial analysis techniques such as nearest neighbor as an example. So let's put everything into practice in a real-world business scenario, and I'm going to demo how to perform this spatial data analysis to identify the best locations for building the coffee shop empire. So let me introduce you the business mission over here. Imagine that you are the CEO of Urban Cafe. So this is a new coffee shop chain, and you would like to expand your business in New York City. Now, why New York City? Just to give some fun facts, in 2024 alone, there were approximately 64 million tourists that visited the city, making it one of the most visited places in the world. And this gives us a huge potential customer base, right? Now, tourists typically explore, walk a lot, and often look for quick refreshments like coffee, making them ideal patrons for Urban Cafe, our business. So our target market is not just the local population, but also this vast and ever-changing group of visitors. Our business goal is to identify the most strategic locations across New York City to open new Urban Cafe outlets. And these should be placed in locations that see highest tourist footprint and have good visibility and are relatively lower competition from other established coffee brands, because we know already that New York City is oversaturated with cafes. So the idea is like, how can we actually use geospatial data and the power of Oracle database, Oracle spatial functions, Python as well, to identify the best locations where we should open new coffee shops. So we know location is everything in this business, and then the project combines data-driven decision-making with geospatial insights to ensure that each new location supports our long-term success in New York City. So what do you do as the CEO if you have this goal in mind? So the first thing that you do is you speak to the market research and tech departments and ask them to work together towards this new goal, right? Now, the marketing analyst will conclude that choosing the best location results from a comprehensive market research, and opening new coffee shops for the potential clientele is driven by three principal factors. The first one is foot traffic. Actually, I would say four, but I'm not going to use the fourth one. You'll see in the data that I have available. The first one is foot traffic, right? And then we will consider areas with high foot traffic as they have an increased potential to generate more revenue. And we'll evaluate potential locations for their proximity to high traffic areas such as subway stations or subway entrances. The second factor is the competition. So we have to analyze competitors' presence and consider potential opportunities in a less competitive landscape. So in our case, no cafes in a specific radius from a considered location. Because if let's say you consider a subway station location and then you have like already 5 cafes around it, maybe it's not a good spot where you want to open a new cafe. Unless, and this is where I go for the third factor, we have to take into consideration the consumer behavior and preferences. What happens is that consumers survey the different coffee shops. So a specific coffee shop would have a rating. Say, for example, we have 5 coffee shops around a subway station, and then they are all rated with low rates. What that means is that maybe there is potential for us to open over there, right? Because our competition does not do so well. And we know that we sell premium coffee and we have already good reviews in other locations. So maybe that is actually a good location. So we'll consider actually the consumer behavior. And then the third one is, the fourth one is the spend in an area. Now, I was looking actually for data to show me the spend in an area, and then I could not really find good data to use for my analysis. Which is why I thought maybe instead of using the spend in an area, I'm just going to use tourist attractions, because tourists spend time and money in areas that are in the proximity of these tourist attractions, right? So in this case, we are going to consider locations in the vicinity of tourist attractions. So for this purpose, you will see that I just picked up a data set, which is tourist attractions locations. So I have the geometries for those. So when you engage with the IT department and ask your data analyst to analyze the data and come up with recommendations in terms of what are the best locations for opening new cafes, they will look at all these factors that I mentioned. Okay, so the first task is to obtain the spatial data, and potential sources are OpenStreetMap data. This provides a collection of key value pairs. For example, a key is amenity and value is restaurant or cafe in our case. This is maintained by the open source community. And we also have, let me just click here. We also have the Overpass Turbo EU, which is a web-based data mining tool for OpenStreetMap map data, which runs with any kind of Overpass API query and shows the results in an interactive map. It has a wizard to show the results on an interactive map, and I'm going to show you how this can be used, how you can download the data in GeoJSON format and all that, okay? I also want to add a note over here that Foursquare, so I'm using all the data from Overpass Turbo except of one data source, which is actually a CSV file, because I wanted to show you how you can actually use also CSV files instead of GeoJSON data, which you extract from any of these online sources. So I'm not using it for this demo, but Foursquare has recently made a significant contribution to the geospatial community by releasing its comprehensive data set of over 104 million global points of interest as an open source resource. And this data set, which is known as the Foursquare Open Source Places, was announced in November 2024. My demo actually was built before that, so if I knew about it, maybe I would have used this data. This data is available under the permissive Apache 2 license, which allows for both commercial and non-commercial use, if you wanted to have a look at that. Okay, so we have to first obtain the spatial data. So we start our geospatial data analysis journey by gathering the 4 types of data sets that I mentioned. The first one is the traffic data. So for the traffic data, I'm using the subway entrance locations across New York City, exported as GeoJSON from Overpass Turbo, and this helps us identify high foot traffic areas. The second is the competition data. So these are the locations of existing coffee shops in New York City, also exported as GeoJSON. And this gives us a view of the competitive landscape. The third data set is the attractions. Now, this is the CSV file that I mentioned. And this is listing the attractions in New York City. Although it doesn't include direct geometry information, like in a GeoJSON, it has latitude and longitude columns that we can use, and we can just actually generate the geometry out of those. And then the fourth data set is the survey ratings. Now, I mentioned that coffee shops are assigned a customer satisfaction rating from 1 to 10. But because I couldn't find that specific data online in a reasonable amount of time, I had to so I had to primarily randomize those survey scores. And then I just had to alter a table and then add this column with the ratings. So this is kind of like a trick if you want. But if you have surveys, you can actually use them as the data source and then just join with your data source, geolocation data source. Okay, so after gathering the data, what do we have to do? We'll create an Oracle Autonomous Database, or ADB, what we call it. And then we'll import the GeoJSON files into Apex to create the tables. And then we are gonna populate the tables with the data from the GeoJSON. And then also an additional step is to prepare, clean, and enhance the data inside Oracle ADB to make it ready for spatial analysis. Okay, so to perform the spatial data analysis, to start, we need a dedicated Python environment, and then this ensures that all the required libraries, especially those for spatial analysis and database connectivity, are properly managed. Next, we connect Python to the Oracle Autonomous Database, and then the python-oracledb driver is a lightweight and efficient tool for this. It supports both thin and thick modes, like I said, for secure and high-performance connectivity. And we'll use credentials and wallet files to authenticate and connect securely to this autonomous database with spatial data loaded. We'll use GeoPandas to load and visualize geographic datasets from the Oracle Spatial data. And then Oracle Spatial offers advanced spatial features directly within the database. And then with it, we can run spatial queries like proximity searches. I mentioned SDONN and SDONN distance. And this helps us derive meaningful insights such as identifying regions of interest, which support informed decision making. Now, last point is to enhance our visualizations. We are going to use Shapely for geometric manipulations and then Folium for those interactive maps. Okay, so at this stage of the project, we've completed our analysis using a scoring and weighting mechanism. And this involved evaluating various potential locations across New York City based on a set of carefully chosen criteria aligned with our business objectives. Each of these three factors considered was assigned a weight based on its strategic importance. And for instance, high tourist traffic might have a higher weight than nearby competition, given our goal of capturing the tourist market. So based on this analysis, we can confidently recommend the top performing locations that best align with the mission of Urban Cafe to expand its footprint in New York City. Okay, so let me go to the demo, and then I'm gonna come back to the presentation because I still have a few slides to wrap up and show you some meaningful resources. All right, so just checking the time. I still have, what, half an hour, right? Okay, I think I should be good. Let me start with maybe showing you the overpass turbo data. So what I have over here, if you just do overpass turbo EU and then you just put a location over here, like I zoomed in on New York City because this is where I wanna, this is my area of interest. And what I did over here, I said, I'm looking for amenities which are cafes. And I simply run this. So when I run it, it's just gonna generate all these points on the map. And if I want to look at the data behind it, it's just going to show me how the JSON is going to look like. And the GeoJSON, I should say. And what I can do with it, I can simply export it. Okay, so I can say download the GeoJSON. And then when it's downloaded, actually, these are my data sources. So I downloaded the cafes, I downloaded the subway entrances, and then I have the CSV with the tourist attractions. So if I open one of these, let's just do text, it's fine. So this should be similar to what let's open again. This should be very similar to, or actually identical with what I have over here, right? And unless there are more, maybe 2025, there's more locations than when I extracted this in 2024. And then similarly, I have subway entrances, and then I have tourist attractions. Like I'm gonna open tourist attractions, so then you can see how this looks like. So this is simply a CSV file, which contains latitude and longitude, but it doesn't have any geometry. Okay, so then a bunch of other um, columns, which may be useful for my analysis. Not all of them. All right, so now when I have all these data sources extracted from the open source geospatial sources, I could actually log in. Give me 1 second. Oh, I think I need my phone for this. Um, Give me 1 second. I need my phone to be able to authenticate because Oracle has all these policies.
While Veronica's getting her phone, we invite you to
Yeah, I'm sorry.
questions in the Q&A box.
Okay, I'm sorry about that. I didn't think it's gonna disconnect me so quickly. Okay, so what I have over here, and I'm actually showing this in the notebook. I already created a database, and eventually I can maybe, okay, let's do this. So I showed you how I fetch my data from Overpass Turbo, and now that data, the data which resides in those three files, I have to load it into an Oracle database. Here I also provide the steps on how to spin a new autonomous database. If you're familiar with this already, then I'm not going to insist, but it's like a couple of minutes process. What you do is like you specify the compartment where you want to create the database, you give it a name. In my case, I said like I want to create a transaction processing database, which was serverless. And then you specify a password for the admin, and I'm using MTLS for the authentication, which means that I can actually download the wallet and then I can connect through the wallet as well. So now I have this database created, and then what I can do with it, I can load all the data using Apex. So these steps were already performed. I'm not going to demonstrate them during this session, but I'm going to show you step by step what's been done, so then you can get an idea of what happened over here. So in Apex, let's try. So I give you all the steps. You can see how I got there. Let's see if I remember the password. Give me 1 second. Oh yeah. Okay, so what you do is you go to SQL Workshop. utilities, and then data workshop. And this is going to give you this utility to load data. So what you simply drag and drop the file over here. And what that is going to do, that's going to read the GeoJSON similarly to a JSON file, and it's going to create a table based on the structure which is found in the GeoJSON. So you'll have the same structure of the GeoJSON is going to be the structure of the columns in the respective table. So I will have ultimately three tables. One table is going to be cafes, the second one is going to be subway entrances, and the third one is going to be tourist attractions. And let's see if this is still on. Oh yeah, of course, everything expired. Okay, let's relaunch. So I have actually a schema which is called workspace GeoPandas. And then within here, I have cafes, and then I have subway stops, and then I have attractions. And just to select quickly from one of them, I thought I had a script. Select star from W. Okay. Cafes. So this is the structure of that GeoJSON loaded into an Oracle database. So you notice I have an ID, I have a type, I have the geometry. Initially it was the geometry actually, but I had to do some data preparation where I had to rename this column to GeoJSON. So then I created another geometry. I'm explaining all those bits and pieces over there. So I think I have like 1,000, let's do a count, 1,100 and something rows over here based on what I extracted from Overpass Turbo. Yeah, 1,193. And then I have subway stops. Let's do subway stops. This is very similar to the cafes. It's just that we get, in terms of columns, we get the coordinates where that subway stop is, and I think there is a description. Not like this. Not everything has a description though. That's what I've noticed. Not everything has a description. Okay, so and then for the attractions, I'm just gonna quickly show you attractions as well. Okay, so I wanted to show you that we have these two columns, latitude and longitude, but there was no geometry, okay? Because the CSV doesn't have the geometry stored. We can generate them. So let's go back over here. After we load the data, I'm showing here how you load the data, how you create that workspace. This is when you put the name of the tables and so on. So I guess I have more, right? These are the cafes and subway entrances and 500 attractions. I think this was just a cut. It was a sample attractions file that I found somewhere, so I just grabbed it. Now, there were also some steps on data cleaning and preparation. I was deleting from cafes because, of course, you cannot rely on everything that you download from those sources. Some of the data has actually, like in this case, there was no name, there was no description, so I could not really tell which cafe is that one. Similarly, in attractions, in that sample file that I grabbed, there were actually rows where I didn't have latitude and longitude, which meant that I could not generate a geometry. So it just performs some basic manipulation, cleaning, data cleaning. And then like I mentioned, I had to add the geometry column on each of these tables. So the GeoJSON data came already with the geometry column when I created the table based on the export. But I wanted to create geometry based on SDO geometry, okay, because this is what the Oracle Spatial data is familiar with. And then, so I do that for all three tables. And then we are going to use Oracle Spatial just to apply those smart functions which the Spatial gives us. But in order to use those, like I also have to create a special metadata and indexes. So this is another step that I had to perform. Now, here I detail all the steps of creating the Python environment because, of course, in order for us to access the data from the Oracle database and display it on a map, in this Jupyter notebook, we are using Python as a programming language or like as an app developer, let's say. And I'm giving all the steps on how to create a virtual environment, how to install the Python. Then there are a bunch of libraries that you would have to install. And not all of them are necessarily needed actually for this exercise, so I will just highlight what you need. This is the driver, the python-oracledb driver. So you issue pip install oracledb, and you install Folium, Shapely, GeoPandas. Now, some of this stuff, actually, it can be like a prereq of, say, for example, Shapely would require Selenium or something like Seaborn or something like that. Then you would have to install all the prereqs for them as well. And then, obviously, I'm using the Jupyter notebook, so I had to install Jupyter Lab and give all the steps on how to install those. And then ultimately, after everything is up and running, Jupyter is running on 8001. You can see over here on a compute box in the same cloud space. This is how I launched it. So I do Python and GeoPandas, which is what I have over here in this link, right? And then here we are. Now we have all the environment set up. And I mentioned that we are using the GeoPandas, and then again, a geodata frame. These are the components, right? The main components, geodata frame and geoseries. The first one is for storing geometries, and then the other one is for handling those geometries. And then I also mentioned that we have two parameters that are important over here. The first one is the CRS, which is, you'll see kind of like every call when I use GeoPandas, are going to use this EPSG 4326 for the CRS, and then the geometry, right? So then tiles get plotted by leaflet when using Folium. That's why we need those. I'm giving some examples here using Shapely. Let me see how much time I have. 20 minutes. Okay. I'm keeping an eye on the clock. So I can show you how Shapely can shape some of those geometries. So in this case, I'm just like plotting a point. You see just a dot over there, and then